Hello again. Okay, we've got. We left off with. Let's see. We left off with the frame, and in the last construction video here, and we're working toward figuring out how to mount the servo motors. Now I've done this before, and I mean there's several different ways. I mean the servo motors themselves. Let me see if I can get there. Okay, servo motor. Okay, the servo motor itself, it's got these two flanges on it that we want to hold it by, and it's got a couple of holes. So, I mean, we've got some options. One is we could actually, put holes in the plastic. We don't actually have to drill them. We can actually have it print them. I mean, or not print the material that's going in there. And that's okay. Then we need screws, and we've got a lot of ability with the printer. So what I want to do is I want to print something that these can snap into, rather than something that requires metal screws. I mean, that's the idea of the printers. We can try to avoid those type of things, and it's marginal, but it'll work. And we're just going to kind of go over what I did, and then you can just copy that piece of code, because there's no reason for you to worry about getting those dimensions right. So we'll just make copies of that stuff. Okay, let me go back to this. Now, this is where we stopped, and I'm going to turn off the frame again. This is the standard way of me doing things. I'll just turn the frame off, so if I hit F5, it all goes away. And we want to keep the ring in there, okay. But I need the servo mount. And what I want is a piece of, this plastic actually, it gets a little bit flexible if you get it thin enough. You get it too thin, it breaks. Okay, fine. If it breaks, it's not tragic. We can always hold it back for tape for the moment. Okay, so I'm gonna copy a piece of code from another OpenSCAD model that I've got, and let's see here. And most of it'll make sense. This is going to be called, let's see, module. Everything's a module. Modules can call modules, so it can get nested pretty deep. And this is going to be a snap joint. And we'll just do this and that. And I better call it so I can see what it looks like. Okay. And now inside here, I'm just going to copy and paste from something that's off screen. It's cheating, but that's okay. I can do that. Okay, so let me just do this and see what happens. Okay, so let me fix the spacing that got kind of messed up a little bit here. Now, this has got a few things. Let me get rid of these things that are commented. Okay, so this is the, if you have something that changes in terms of, I'm going to use it in a whole bunch of different places, but I want to be able to adjust it, you can actually create what they call a variable here too, just like we do in our programs, and set it to a value. We don't want to set it to, it doesn't work quite the same, so you can't loop like we do in the programs. At least not this way. There is a way, but there's some messiness to it. But okay, so I got a snap joint, and this is a servo mounting plate. MPT is what I'm calling that. And that's how thick that plate is, that the little tab sticking out. And then, because I've seen some that's slightly different. I think these are 2.5. The servo slots, spring levels, those are just numbers. Okay, and then I build something. And when I say draw it, we get this. Okay, I tried several times to make this work right. And at first you're like, well, what the heck is that? What you could see in the servos, the side edge of the servo slides into here, and this middle pin will flex just a little bit to let us get it in there. And then when it's in there, it kind of snaps into place. Now in the last video, when I was talking about the printer limitations, I've got this overhang here that gets printed up into nowhere. Is that a problem? Not really. I mean, it's so small. It's only it's only like a millimeter. So it's small enough that it's just not going to cause us that much grief. And this is built out of, I mean, you can look at the design. This is all cubes with differences, cubes subtracted out. So I mean, to make this whole thing and then subtract stuff out. There is a risk of this breaking off in here, the middle one. And if it does, we'll just jam something in between here and this other post that's much stronger. Okay. So there's one joint. That'll hold one side of the servo. We need a second one. So let me just okay. That's snap joint. What did I do for the other one? I called it, let's see, what did I call it? I need to have a second one at a specific spacing. Okay. Well, that's one snap. I see. I'm getting ahead of myself here. Let me change the name of this a little bit. This is just let me call this one snap instead. I make my mistakes too. Okay, and this one will be called module snap joint, and I need to close that. And that looks like, sorry for the background noise. Okay. So we've got this, and let me fix a few things, because as I said, this is copied from another piece of code that you can just use. And one snap is there. So now if I tell it to, okay, so this is stuff that you can just copy straight into yours. So now if I say redraw this, I've got this. You know, if I take that model of the servo itself, we could put it in here. So let me just take the servo and just put it in here. Okay, it's not going to be quite right, but let me just say servo. Is that what I called it? Yeah, I just called it servo. So if I just say this, I get that. It's not in the right spot. Okay. I was guessing it wasn't going to be. But what I can do, let's make a blue. That way I can really see the difference. First off, let me try to get centered a little better here. It needs to be rotated. So let me add some rotate and translate to this thing. Rotate. And if I look at the XYZ, it looks like I want to rotate it in the X direction. Okay, around the X axis. So that'd be 90, 0, 0. Okay, that is rotated where I want it. The servo's not where I want it. Now, do I want to move the bracket or the servo? Okay. Let's move the servo. Okay, so I want to translate. I'll add translate to the front of this. 0, 0, 0. If I do redraw, nothing changes because I said don't move it anywhere. We need to go up. So let's just start moving this thing up. Let's say, you know, it redraws so fast. There's 10. Is that far enough? It has to be above this notch because that's going to sit right in this notch here. So we need to come up a little more. So let's go 12. 12. That's really close. Let's go 12.5. Is that too far? Let's go 12.2. Okay. I could see a little gap on the top side. That's what I want. And I can see a little gap on the bottom side. That looks like it's about right. Okay. So now, let me zoom back out here. Back in. I want this thing slid over here so this gap goes away and this clears this thing here. So that's going to be, that's in the minus X direction? Let's go minus 10. Way too far. Let's try minus 5. That's not bad. Okay, so now I need to slide it back, which is obviously the Y direction, and it looks like it's plus Y direction. So let me start with 10 again. Not anywhere near enough. Let's go 20. Ooh, that's getting closer. Is that right where we need to be? Nah, it's got to go farther. Okay, 22. Let me go a little bit farther. 23. Okay, what I'm looking at is the gap here. I want this edge to slide over, be right up against this. So that's 23, 22.5. Let's see, how much does that move it? Okay, move me a little bit. Let's try 6. Oh, 4. Got to go the other way. You know, I'm tempted to leave it there with just a little bit of gap. Now we'll turn this back off when we go to print because we can't print the servo. It'd just get in our way. Okay, so there's a servo with mount. Okay, so when I want to turn it off, I just put these 2 slashes in the front. And then when I hit F5, it goes away. But when I'm trying to design this thing, I need to know where this gear head is, so I know where things happen. So I can leave this on. Okay, so there's snap joint. Okay, so now we can go back to our frame. Let me turn off snap joint for the moment. Let's go back to our frame. Now I want a servo in here. Okay. In fact, I may want more than one. There's all sorts of ways of doing something. I can call not where I want it, but it's on the board. Okay. And notice that as I've designed these things, everything is right on the 0 line. So when I print it, it doesn't have a problem. If it was sticking up in the air just a little bit, it would be a problem. Because if I let me break it for a second here. Let me translate. Let me just take the servo mount up. So you can see that this is no longer in the ground. So when it goes to print that first layer, this is, it's going to print this. It's not going to print this. And then all of a sudden it gets up to, a couple millimeters up. It tries to come out here and actually print this, and it makes a mess. If you print it with supports, then it tries to print supports down here, and the surface gets really rough, and it really doesn't do us any advantage. So we really want to keep that right at the surface. Okay. But that's probably not where we want it. Let me rotate it. I'm going to put the rotate over here. And I want to rotate it in the Z-axis because I want to turn it, So, I make mistakes on which way I'm turning things, and that's okay. I mean, we're just playing with numbers at the moment. I think I want it turned the other way. So let me go minus 90. That's not bad. We're kind of hanging off the edge of the cart. Let me slide this sucker. Here's X is this way, Y is that way. Okay, so let me slide it in the Y direction. Let's see. Y direction is right. This is X, Y, Z. Let me go 30 millimeters that way. Okay. Now I want one on the other side. Okay. Let me copy that. Paste that. Now, my problem's going to be, let me move the translate over. I need to move it in the, looks like X direction. I think this is 80 wide. Let me just do that, and then so it's just not on top of each other. Okay. Now it's facing the wrong way. Let me rotate that sucker around. So let me make that minus 90 the plus 90. Is that all I need? I mean, these two are not in line. If they were wheels, if this thing actually went all the way around and they were wheels, then you'd have a, they're not in a line. If that bothers you, you can actually just shift this up by whatever amount that is. But the way the servo snaps in here, that's symmetrical anyway. So we can just pick the servo out, flip it over, and snap it back down. And then it would line up okay. Okay, let me turn off the servos for the moment. Go back up into snap joint, put 2 slashes there, comments it out. So this is what it looks like now. I don't have anything connected to the servos. We still have to do that. But, you know, this is probably not too bad. So, again, I don't expect your frame or robot or anything to look like anything that we've done. We haven't actually decided what it's going to do. I'll think of that today. But what we'll want to, you know, it's going to have to move. So there's, you know, something to help get us some motion. We've still got the problem that it's only 180 degrees and we need to move, you know, keep moving forward. So we're going to have to do something funky with that. But this at least gets us a way of mounting the servos down. And in the next video, I think we'll go just a little bit farther and then we'll do a test print. And so you can see the process that I go through to actually create the files for the printer and then actually run it through the printer and give you an idea how long something takes. Because and I'll do a time lapse of the actual printing process. I think that would be useful too. Okay, so let me just stop here for the moment. We're getting a little bit long. And this was version 2. No, we should have really made this version 3. I haven't saved it as yet, so let me just save as. Version 3. Okay, save. Okay. Everything's saved. Great. See you next time.